Alright, so we're going to talk about graphing the basic square root and cube root functions. And we're going to start off really basic because then the next thing I want to do is transform all of them. And so the square root. And so I'm just going to pick some x's. I'll explain here in a second. So first off, I want to pick a -1 because when you take the square root of -1 you get I, which is imaginary and it doesn't show up on the graph. So it's essentially gone. Square root of 0 is 0. Square root of 1 is 1. And the reason I'm picking these so far is just because usually we start around 0, but then I skip to 4 because I can take the square root of 4 and get a pretty number. It's a perfect square. And I pick 9 again because it's a perfect square, and you get the square root of 9 is 3. So then you can plot these points: 0, 0, 1, 1, 1, 2, 3, 4, up 2, and then over 9 and up 1, 2, 3. So this is our basic square root graph. One thing to notice, that there's nothing to the left of it. Nothing to the left of the y-axis. Why is that? Well, right here. When you take the square root of negatives, you get imaginary numbers, and imaginary numbers don't show up on the real number line. So we say all the x's we're allowed to plug in, they're a little bit restricted because we can't put our negative numbers in. So we say the domain is everything greater than or equal to 0. We can't plug in negative numbers. And our range, all the y values, we don't get anything below the x-axis. So the first number we get is 0 there, and so our y value is also greater than or equal to 0. This inequality shows up a lot with y equals square root of x. And I want you to know this, just like we did with our parabolas, this general shape. If you go right 1 and up 1 because the square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. So, cubed root graph. Very similar, but cubed roots. So we can take the cubed root of negative numbers, and so I'm going to put 0 right in the middle this time. The cubed root of 0 is 0 because 0 times 0 times 0 is 0. And then I'm going to pick -1 and 1 because they're both cubed roots. 1 times 1 times 1 is 1. Cubed root of 1 is 1. -1 times itself 3 times. And then the next cubed root, in the last table we chose 4 and we chose 9 because they were perfect squares, but the first perfect square is 8. Sorry, the first perfect cube is 8, and then on the opposite side. So we get the cubed root of 8 is 2, and the cubed root of -8 is -2. So we can plot those points. 0, 0. 1, 1, -1, 1. We can go over 8 and up 2. We can go to the left 8 and down 2. And so this is our basic cubed root graph. And we're going to stretch it. We're going to shift it left and right, up and down. But that's the basic gist. If you can remember that it goes to the right 1 and up 1, to the left 1 and down 1, when it's positive, and just the basic graph, and that you can go to 8 because of the cubed root of 8 is 2, you'll go far. Our domain and our range were restricted before because we couldn't take the square root of negatives, but now we're talking cubed root, and you see that our graph doesn't stop to the left or stop to the right. So domain is all real numbers, and we just use that symbol to represent all real numbers, meaning we're not restricting it at all. Just like an R with the paragraph sign. We've talked about that before. And then the range is all real numbers again, because all our y values can be anything they want. Now, it almost looks like it's not going to get very low, and that's just because it's not getting low very quickly. But as you go further and further to the left, it's going to keep going down. There's no asymptotes, as we call them there. It's just going to keep going down. So again, know these basic functions, because in the next part we're going to go and shift them up, down, left, and right, and we're going to want to keep the same function rather than plotting points every single time. We are going to plot points, but rather than making a table every single time, we want to make sure we're good with just the shape of the graph.